Okay, so here we go. Today we are just doing a little intro to the trig that is going to be the hardest of all of the trig, which is the identities. Okay, so this stuff shouldn't be bad. One little bite at a time. It's not that bad. Okay, first of all, I want to go back to the unit circle. So everybody make a quick sketch of the unit circle in your notes. Not the whole unit circle. We're just going to focus in on one little part of it here. Over here on the right-hand side, we have a triangle. And in that triangle, we have one of those sides has to be 1. Can you see it? All right. Excuse me. Focusing. All right. All right, so in this triangle, this side is 1 because we're in the unit circle. This side is x because that's how far over to the right we go, and this side is y, all right? And then this is the point right here called x comma y. That's the simplest way. Now if we talk about it in terms of sine, cosine, and tangent, the sine of anything, this angle right here is the interior angle, the sine of that is the opposite over hypotenuse, which is y over 1, which reminds us that wherever we see the y, we're seeing sine. So over here, that part right there is really sine of theta. You should always put a little theta there. All right, next one is, of course, cosine. Comes out to be adjacent over hypotenuse, which is x over 1, which is x. So cosine is x. So this is cosine. But where's tangent? Tangent is y over x. We don't see it on this picture. But if we extended out a line out here, that would be the tangent on a picture. We'll talk more about exactly where, how long that is and stuff later. But the point is that the tangent part is y over x, which is sine over cosine. All right, so you need to understand where these are coming from so that later, when I start replacing tangent with sine over cosine, I can do that, right? They're equal. So wherever you see this in a problem, tangent of theta is, and let's say we're going to multiply it by cosine theta over sine theta, you could make a really smart substitution here and pull out the tangent theta and put in what? Sine over cosine. Sine over cosine is tangent. So I could put sine over cosine right here. Sine theta over cosine theta. And why is that smart? Because now that's going to cancel that, that's going to cancel that, and the answer would equal 1. So if you know what to substitute in, it can help a lot. So that's why I'm telling you this. Tangent is sine over cosine. If tangent is sine over cosine, what is cotangent? Cosine of theta over sine of theta. So wherever I see cotangent, I can replace it with cosine over sine. All right, next logical leap. See if you can hang with this one. If I go back to that original unit circle triangle that's got this is cosine, and this is sine, and this is 1, wasn't that a right triangle? What do you know about right triangles that's true? Pythagorean theorem, which is what? A squared plus b squared equals c squared. So cosine squared plus sine squared would equal 1 squared. You're exactly right. You've just written out the Pythagorean identity. All right, so this is a true statement. It's only true when the domains are right. If you are outside the domain, it won't work. That's why it's not just a equation. This is called an identity. It only works for certain domains. But bottom line is that a squared plus b squared equals c squared. So cosine squared plus sine squared should equal 1 squared. Do you get that? All right. Now, here's how you normally write it. See how that looks a little cleaner than having all the parentheses around it and stuff? That's how you normally write cosine squared plus sine squared. The whole squared right there is equal to 1, and there's no sense in squaring it because 1 squared is 1. So what if I asked you, what is sine squared? You could just tell me an answer. You're warm. 1 minus cosine. So there's a typical R2 question. What's sine squared of theta? It seems like it's like, well, what do you mean? What's the angle? I don't know anything, but you do. So use that same thing and tell me, what's cosine squared of theta? Cosine squared theta would be 1 minus sine squared theta. Because I'm just solving for this, so I subtract sine squared from both sides. And I get this. So wherever I see a cosine squared, I can put a 1 minus sine squared if I want to. It's just a substitution. It's like what it would be handy if I had something in sine. And so I got this problem that's got a cosine squared in it, and it'd be really nice if it had a sine in it. Well, I can just substitute. I can put this in instead. I can put that in for cosine wherever I see it. All right. Okay, here's another set of things. These are not really identities. They're just like definitions. And you probably already know most of them. I already went over what cotangent and tangent are. Remember, tangent, I'm just abbreviating now, is sine over cosine, right? And what's cotangent? Cosine over sine. What is cosecant? One over sine. I should put a little angle. Cosecant of theta, or x, or whatever. 1 over sine. And what is secant? 1 over cosine. So wherever I see a secant in a formula, I could replace it with 1 over cosine, couldn't I? Let me give you an example of how you might use that. So here's a typical problem. We have cosine theta times secant theta. Let's say that's the problem. And you go back to your book of like identities, or in your mind you have to think of, well, what could I substitute? I could pull out one of these two and put in the other. Here it is. Secant of theta is 1 over cosine. So if I have this is really 1 over cosine, I can rewrite the problem as, instead of the secant, I put in 1 over cosine. And you see how they would cancel each other out, and the answer would be 1? Can you get that? All right. So let's say we had something like this. Well, first of all, what's that one? You have it on your sheet from before, but in case you forget, you can always go back and just rewrite out the original one. Do you remember how it was cosine squared plus sine squared is equal to 1? Remember that? So then we can quick solve it and get what? 1 minus cosine squared. But what if I wanted my answer in secant? What if they said, you can't give an answer like that. You have to give an answer in terms of secant. Then you're doing a substitution for this part, and you're saying instead of cosine, you could put what? So you could have 1 minus 1 over secant. No, this would not cancel out the ones, but there's your answer in terms of secant. Okay? So you did a double substitution. The first thing you said was, well, I know sine is really 1 minus cosine. And then I know cosine is really 1 over secant. And so there's my answer in terms of secant. All right, so you just need to know a bunch of things that you can substitute, swap back and forth. You know, like if this would work better, I'll stick that in there. All right, so like if you had a problem with 1/2 0.937x, what substitution could you do here that would be really simple? If you're going to type this into your calculator, what substitution would you probably make? Instead of the 1/2, you use what? 0.5. That's a substitution. Why? Just because it's simpler and it makes it easier to multiply a decimal times a decimal. Okay? That's a substitution. Well, same idea if you're in a problem like this. You can do substitutions. You can either replace what's in here with something else, or you could replace what's here with something else. And just substitute. Okay, so let's get some ideas. Do you recognize this one? 1 over sine sounds like the flip of sine, the evil twin of sine. Okay, so if this, I'm going to leave this as secant. I could replace this with what? Because cosecant is 1 over sine. What if they didn't want you to leave your answer like that? What if they wanted the secant to be changed to? Secant would be the same as 1 over cosine. And then if you had to multiply them together, final answer, this one's like a fraction and the cosine's on the bottom. Do you see how it would come out to this? All right, so you're doing lots of substitutions, and yeah, what it really boils down to, if you took nothing else away from today because your brain's too fried with all the big tests and stuff that you're taking, this is the big one that you got to leave with today. A squared plus b squared equals c squared, so what? Cosine squared plus sine squared equals what? 1 squared. Because it came down to this little circle here where that was 1 and that was cosine of theta and that's sine. Okay? And where we're going to go with this for tomorrow is, or for Monday, is where we take this to the next level, which is let's see what would happen if I divided everything by sine squared. Isn't it okay to do that to an equation? I can take and divide everything by something, so I can. So what does that turn into? 1. Does anybody recognize cosine over sine? It's a little hard, but some of you might. Cotangent. See, it's not tangent. Tangent would have been sine over cosine, but cotangent. But notice these guys are squared. Is equal to, and what's? Uh-huh. So we just figured out what cosecant squared is.
Then you could easily figure out cotangent squared if you want.
Exactly. If you need the cotangent, you just subtract 1 from both sides, and you'd say cotangent is cosecant minus 1. All right. Good.
0.5 to 3.
All right, that's enough for today. Your homework is going to be that Algebra Ninja thingy.